Okay, 5.10 linear combination video lesson. Notice that we didn't do 5.9. Don't worry about that. And when you see linear combination, you should be thinking systems. This is what you did in Algebra 2 and before when you saw systems. I'll explain how that plays into trig here in just a minute. So a cosine x plus b sine x is equal to c cosine x minus d. So what this means is we can have a cosine added to a sine with different amplitudes equal another cosine with a different amplitude with also a horizontal shift. Okay, that's graphically what we're doing here. Now notice that there are four unknowns. What you're going to be given is the left-hand side of this equation. Okay, and so you're essentially going to be given an a and a b value. Now with that a and b value, you can find c. And if this reminds you of Pythagorean theorem, that's because it is Pythagorean theorem. So once you identify a and b, you can find c. And then once you know c, you can then use this last two statements to then find d. You need both of them to find the correct d. Okay, so let's look at this. This is not a proof or solving. It's just transform into a single cosine expression. So what they're saying is they're giving you the left-hand side. They want you to write it as the right-hand side, identifying c and d. So first off, we need to figure out, well, what is a and b? A is the coefficient in front of cosine, or cosine's amplitude. That's root 3. B is the same thing for sine. Since there's nothing there, we think there's nothing, but really there is a 1. Okay, so now what we need to do is to find c. Now c is the square root of a squared, so root 3 squared plus 1 squared, b squared. And this gives me the square root of 3 plus 1, which is 4. So c is 2. Okay, c is 2. And this ends up being a 30, 60, 90 triangle. Doesn't really help me so much, but it will kind of explain then what d is. But if you hadn't realized that, that would have been okay. All right, so now let's write two statements. First off, we know that cosine d is equal to a over c. So a is root 3 and c is 2. Now, all these numbers have been positive so far, and that won't always be the case, but we're just going to go with what they give us, okay? And then we also know that sine of d is equal to b over c. b is 1, and again, c is 2. So you're trying to identify the d such that when you take cosine of it, you get root 3 over 2. When you take sine of it, you want 1/2. Now, because both the cosine and the sine are positive, I know I'm in the first quadrant. That won't always be the case, but that will help simplify things. So we got to think, well, what is d? Okay, it's just like saying arc cosine of root 3 over 2, okay, and also arc sine of 1/2. And if you want to write that down, that might be helpful. Arc cosine of root 3 over 2, oops, and then arc sine of 1/2. So that's a 30 degrees. All right, let's keep it in radians, so that would be pi over 6. Okay, once you get to this step where you found c and d, you can actually do the transformation. Okay, you're using this side. So it's going to be c, which is 2, cosine, parenthesis, x minus d, and d is pi over 6. Graphically, you could graph these two, one in y1, one in y2, and it will give you the same graph. You can compare the tables or the actual graphs. Okay, let's look at the next one. Let's do the same thing. Okay, so notice that x here is 5x. Don't let that trip you up too much. But one thing that I'm going to do is actually rewrite this into cosine 5x plus sine of x. 5x. And the reason I wrote it this way is if you look on the left-hand side of the equation, cosine is first, or cosine has the a. So here, a equals -1 and b equals +1. You didn't have to rewrite it to figure that out, but it helps. Okay, so now let's find c. So remember that c is the square root of a squared, so -1 squared, plus b squared, so 1 squared. So that gives me square root of 1 plus 1, or square root of 2. Okay, now that I know c, I can set up my two expressions, trig expressions, to find d. Alright, so I know that sine of d is equal, oh, I'm sorry, let's do cosine first. Okay, cosine of d is going to equal a over c. I'm getting this from the top of the paper. It's also on your blue sheet. Cosine of d is negative 1 over root 2. It's important that you keep that negative here because it's going to put you in a different quadrant. All right. I also know that sine of d, I'm looking at the top of the paper, is b over c, 1 over root 2. Okay, so if cosine is negative and sine is positive, what quadrant does that put you in? Okay, it puts you in the second quadrant. So know that your d value is in the second quadrant. Well, what's the reference angle? Okay, 1 over root 2, that's the same as root 2 over 2. That's a 45-degree reference angle. So in radians, that's pi over 4. In the second quadrant, that gives me 3 pi over 4. This is why it's so important that you do both problems, because if you had only been looking at sine of d, you would have thought maybe you were supposed to be in quadrant 1. But I can see here that because cosine's negative, I should be in quadrant 2 for d. Okay, I know what c is, I know what d is, so I'm ready to write the problem. Remember that it's c cosine x minus d. So c is root 2. We've got cosine, parentheses, x minus d, which is 3 pi over 4. Okay? And keep in mind, to get this, I'm just using the right-hand side of that expression, c cosine x minus d. Okay? All right, let's use this in a problem. So here's a solving problem. If you notice the left side here, we could have never done anything with this problem before. Oh, I just realized I made a mistake, and I was trying in my head to make sure I didn't make this mistake, and then I made this mistake. Okay, see these 5x's here? We can't ignore that. That means that I should have a 5x right there. Okay, that's it. All right, so let's look at this problem. Last problem. Again, I have a 2x. I've got to keep that in my problem at the end. Okay, don't forget it like I almost did on that last one. But first thing I need to do is to rewrite this. Oops, not all the way over that way. But I need to rewrite this into a single cosine expression, and then I'll be able to solve. All right, so I'm going to go over here, and I'm going to rewrite. Negative, I'm actually going to write the cosine one first, sorry. I'm going to write cosine of 2x minus root 3 of sine of 2x. Okay, here that would tell you that a is 1 and that b is negative root 3. So then let's find c. C would be the square root of a squared plus b squared. Okay, so this will give me square root of 1 plus 3. Okay, so that's 4. So c actually ends up being a whole number here, 2. All right, and then I'm going to do my two expressions. Cosine of d is equal to a over c. A is 1 and c is 2, so 1/2. And then sine of d is going to be equal to b over c. So that's negative root 3 over 2. Let's think about what quadrant we should be in. If cosine's positive and sine is negative, that's quadrant 4. Okay, so D should be in quadrant 4. And then let's think about what the reference angle is. Okay, so you can use either one to figure out the reference angle is 60. And so that would be pi over 3. But in the fourth quadrant, I would have, I can either write my answer as 5 pi over 3, or I could have written it as negative pi over 3. That would have been okay as well. Either way. Okay, so I'm just going to go ahead and use 5 pi over 3. Could have used either one though. Doesn't really matter. All right, So I know A, B, C, and D, so I can transform this. So all of this now ends up just being scratch work to transform this. So remember, it's C cosine x minus D, so C is 2, cosine x, but in this case it's actually 2x, okay, minus D, which is 5 pi over 3, okay, and that equals root 3. Now from here on out, this is not new, but it's been a while since we've done a general solution that is this complex. So let's review how to do these steps. So I'm going to divide by 2. Okay, so that's going to give me cosine of 2x minus 5 pi over 3 equals to root 3 over 2. And now that I've isolated the cosine completely, what I'm taking cosine of, okay, the argument, is going to be equal to arc cosine of root 3 over 2. Okay, so again, I need to figure out, just like before with general solutions, I need to figure out, well, what is arc cosine of root 3 over 2? Well, that's going to be 30 degrees, okay, or pi over 6 in radians. And then I'm going to add in plus 2 pi n, because these are general solutions at first, then I'll get to that part. Now, immediately, before I even take another step, I need to go through and write my other general solution. What is the other quadrant that when you take cosine, you get a positive root 3 over 2, or just get a positive at all? That would be quadrant 4. And so my other solution here would be negative pi over 6. I could have also put 11 pi over 6. And what I'm going to do here is really make sure this is divided. Okay, could have put 11 pi over 6 there. Same thing. All right, now solving for x, adding 5 pi over 3. Now on this side, when you add 5 pi over 3, you need to get a common denominator. So this would be like adding 10 pi over 6. So that's going to give me 11 pi over 6 plus 2 pi n. And then when I divide by 2, divide by 2, divide by 2, I get x equals 11 pi over 12 plus pi n. That's one of my general solutions. Now let's go over here and find the other one. So add 5 pi over 3. And again, when I add 5 pi over 3, it's like adding 10 pi over 6. So that would give me negative 9 pi over 6. Let me just 15 pi. Which simplifies to negative 3 pi over 2. And then plus 2 pi n. Then you want to divide by 2 again, everything, so that you just get x equals, now this is going to become negative 3 pi over 4 plus pi n. Now I know I'm going through these fractions pretty quickly. Please ask though in class if you have questions about that part. I'm just assuming that you really know how to add, subtract, divide, multiply fractions, all that stuff. But you can definitely come in for tutoring or ask me questions in class if you need to. Alright, so those are the general solutions. It didn't actually say to find them, but that's kind of a key part to actually finding the particular values. So if you think about it, and I write down 11 pi over 12, that's actually not my first value. I'm going to go ahead and write it down though, because it is a value. Okay, but if I come over here and I add, I just realized that that's not a negative. I'm catching my mistakes left and right. I apologize about that. When I added 10 pi over 6, some of you might have noticed and were thinking, Miss Brooks, you don't know what you're talking about. It happens. This is why you always check your work and you look at it, and because it's real easy to make these mistakes. Okay, so when you add 10 pi over 6, you get positive 9 pi over 6. I wrote a negative there, and that was a mistake. Then I divided by 2. Okay, always check your work. Okay, so then which is bigger, 11 pi over 12 or 3 pi over 4? Well, they're both pretty close to 1. This is how I would think through. They're both really close to 1. 11 pi over 12, much closer to 1. So we really should put 3 pi over 4 first. Okay. Now, if I add pi to 3 pi over 4, will I be within the first revolution? Yes. Okay, that would be like adding 4 pi over 4, which would be 7 pi over 4. Same thing here with the 11 pi over 12. If I add pi, that's like adding 12 pi over pi. Okay, that's going to give me 23 pi over 4, which is just, or I'm sorry, over 12. This is just barely less than 2 pi. And these are my 4 particular values. Now that is a lot of steps, but each step individually is not that bad. Okay, but it is going to take some practice. Bring your questions to class tomorrow. The second half of this worksheet we're going to do in class.